My name is Josh Fitzgerald. I'm a research associate here at Virginia Tech in the Small Greens Breeding and Genetics program. Today I want to talk to you about Fusarium head blight, more commonly known as head scab. It's caused by the fungal pathogen Fusarium graminearum, and as you can see, we're here in our scab nursery today, and if you'll notice, you can see that we have the irrigation set up behind us. And the reason being is that you may be familiar with the disease progress or the disease triangle, and that is really what encompasses disease, and it incorporates three main factors. Number one, the host; number two, the pathogen; and number three, the environment. And so the environment here in the Mid-Atlantic region is very conducive to scab, along with our cultural practices. So more and more epidemics are becoming prevalent in recent years. And so if we think about the disease triangle, our small grains are most susceptible to Fusarium infection during anthesis or flowering. So we broadcast our corn inoculum during the boot stage in order to allow the pathogen time to begin to sporulate, and in conjunction with the rising temperatures and the irrigation, the mist irrigation actually splashes the inoculum up into the canopy in a critical period of flowering and pathogen moving up onto the wheat head. Now, with scab being such a prevalent disease in our area, it continues to be a top priority of our breeding program. In our wheat, we've been focusing specifically on incorporating the gene FHB1 as well as other validated genes in QTL for Fusarium resistance. And we do so by utilizing marker-assisted selection, that is markers, molecular markers that are linked to the genes of the QTLs, along with the double haploid technology, offers us a great potential to accelerate the breeding and release of varieties having FHB resistance. Similar efforts are ongoing in our barley research program as well, but until they will be more effective once we identify new native sources of resistance to FHB and identify those tightly linked markers as well. There are certain agronomic traits that make it a little bit more difficult to breed for FHB resistance in barley. For instance, height, flowering date, as well as the head type are all closely associated with disease resistance. With increased interest in winter malt barley breeding, it's led our program to initiate a winter malt barley breeding in order to supply not only the new brewers in our area with quality raw materials, but also germplasm with resistance to FHB. We're excited to announce that in 2020, our program will release its first malt barley variety, Avalon. It was previously designated VA16M81. This variety has exceptional malting quality characteristics as well as moderate resistance to FHB. In 2019, we also released an elite feed barley, VA11B141. It is now being marketed by Seedway as SB255. This is a long-on variety that exhibits increased level of dawn resistance of 3 to 6 parts per million in comparison to the cultivars Atlantic, Secretariat, and Thoroughbred. And then finally, our barley program is excited about the release of a new line, a new hullus barley line, VA15H73. Now this is a high-yielding superior cultivar that has great level of resistance to FHB. It exhibits somewhere between 12% lower FHB index values compared to our Czech cultivar Eve, and it also has superior resistance to the accumulation of dawn. So also in our wheat program, we've had considerable efforts since 2016 to utilize the marker-assisted selection. And it has resulted in a pipeline of breeding material that is entering that program with resistant alleles for FHB. In 2020, we have 7 lines that will be entered into the Virginia state tests that have been developed out of this program, having added resistance to FHB, along with exhibiting yields of 15 to 19% above the trial means for the 2019 Virginia preliminary and advanced tests. The scab research continues to focus on research regarding many different facets. First and foremost, which I previously mentioned, is that there's a critical need for new native sources of resistance in our whole barley program, as well as molecular markers linked to that resistance to aid us in selection in that regard. And secondly, we're collaborating with researchers at the USDA, at ARS in Aberdeen, Idaho, and we're evaluating around 200 lines from that program for resistance to FHB in our area as well. A second project that is currently ongoing with that group is regarding trying to improve the correlation of disease severity with dawn accumulation post-harvest, and we're doing so by evaluating fungal biomass samples to assess Fusarium, and we do that by a quantitative PCR method. And so we've seen exciting results, pretty good correlations in 2018 and 2019 in that regard. And then finally, we're working with Dr. Oakes and Dr. Lee at the Virginia Tech, part of the Virginia Tech Smart Farm Initiative, to explore the ability of utilizing a drone outfitted with hyperspectral imaging, specifically to collect NDRE and NDVI values in conjunction with our visual methods of evaluating the disease. And we're trying to see if there's a good correlation between those visual and the drone images. And so this is very exciting from the standpoint of this has the potential to greatly reduce the amount of resources we need in the field during the time of evaluating FHB, as well as giving us a new standardized method of evaluation, and we're very excited about how that could give us the ability to assess the disease throughout the growing season. So a few things I want to leave you with. First and foremost is that the current production practices of selecting resistant varieties, as well as the fungicide application, continue to be the primary means of control of Fusarium and blight. I'd like to encourage you to visit the Scab Smart website developed by the U.S. Wheat and Barley Scab Initiative, and there you'll find more information on wheat and barley varieties in your area that are resistant to FHB, as well as information on fungicides and their efficacy. I'd also like to point you in towards the direction of subscribing to the Fusarium risk assessment tool provided by Penn State University. This tool, if you want to receive notifications regarding disease forecasting, as well as the possibility of epidemics in your area, all you really have to do is enter your wheat variety, whether its level of susceptibility, as well as the date to receive the risk assessment. And so we'll provide those links in the